Hello, Sridhari. We'll wait for 2 more minutes before starting the session. All right, Sridhari, I have allowed your mic. Can you please confirm if my screen is visible?
Yes, sir. Your screen is visible clearly.
Okay, thank you. All right, let's start the session.
Okay, sir.
Yeah. So, hello everyone. Welcome to this extra session um, on the topic effect of admixtures on durability of concrete. Uh, and this is a part of the NPTEL course Maintenance and Repair of Concrete Structures NOC 23C06, which is taken by Professor Radhakrishna G. Pillai of IIT Madras. I am Ashirwad Satpathy. I am a PMRF research scholar at IIT Delhi, and I was also the officially assigned teaching assistant for this NPTEL course. And this is the last weekly discussion and doubt clearing session that are taken by the teaching assistants of this course. And I decided to come up with a topic on my own to share some ideas and results and data related to the effect of admixtures or chemical admixtures on the durability characteristics of concrete. So um, I've also pasted the link of the week 12 session in the meeting chat. If you want to check it out, you can do that. And also the slides link has been pasted in the meeting chat as well. Now, this is a brief introduction to the topic. As we know, concrete is the second most used material in the world. And as we have also studied in this course as well, not just adequate structural design is sufficient to ensure that the structure attains its service life completely. It performs desirably and adequately throughout its service life. Only structural design cannot ensure that. We have to take care of the durability aspects as well. So we have to move from a strength-based design to a durability-based design. We have to move from a prescriptive design approach to a performance-based design approach. And we have also seen that repair and retrofitting strategies of reinforced concrete structures or I mean um, pre-stressed concrete structures as well is very expensive. It entails a huge cost, and this cost is sometimes almost of the order of the of building a new structure as well. So if these repair and retrofitting techniques are not executed uh, properly in the site, then this results in only wastage of money, because after a certain time it won't even the repair work won't even last for the desired period of time, and this all of this effort goes in vain. So we are losing money, and we are not able to achieve what we are desiring. So therefore, we need to adopt suitable measures in concrete design itself, in the design phase of concrete, not just structural design, but in the material design as well, to enhance the durability aspects of reinforced concrete structures and pre-stressed concrete structures. Now, before going deeper into the subject, I would like to just briefly introduce, give you a brief idea what is durability. Like, we have been discussing durability and repair and maintenance and retrofitting all along the duration of this course, and I just want to discuss it briefly. What is durability? In very simple terms, we can define durability as ability of a material or a structural element to perform desirably under a certain environmental exposure. And this part of the definition is very important: under a certain environmental exposure. Sometimes we have heard, as civil engineers, it hurts a lot, but we have heard people say that the ancient structures that are still existing beyond 2000 years, like the monuments, the old monuments, they do not have any degradation. They are still existing till now without any signs of degradation or needing any repair or maintenance work. However, in today's world, the structures that we're designing in the modern world, those require a lot of maintenance and repair work. And even though we have gone ahead in technology, but we are going towards a lower quality of materials. It is not about the quality of materials. First of all, there are two aspects to it. From what I understand, is that the first aspect is that after the in the modern design of structures, at least in the limit state based approach design of strength, this mechanical design of structures, what we ensure is that we want an economical design, and we allow for deformation to occur, but within a certain level. We allow for the deformation in the structure to occur, but within a certain level, so that the structure completes its desired service life without major structural damage and risk to the life using it. So, however, if you compare this design approach with the ancient structures, the ancient structures are very over designed. They have a lot of redundancies, and the cost was not a concern in those days. They didn't. They wanted to show off their wealth, and let's not go into that. But yeah, so these are two aspects to it. One is an economical design, and the other is a um, we are allowing deformation to occur. And the second part to it is environmental exposure. With the passage of time, the environment is becoming more reactive. We are facing higher temperatures these days. There is issues of global warming and everything else. There are exposure to different chemicals from the industries, and these are affecting the structures even more as compared to ancient days. So now, uh, what is durability governed by? It's a complex phenomenon, and it is basically governed by either the internal properties of concrete, that is the material properties of concrete, or by the environmental interaction of concrete due to certain effects, or by the combination of both. It could be due to the combination of both as well. Now, there could be physical durability effects and chemical durability effects. As we have studied, physical durability effects could be like wearing out of concrete surface, cracks resulting from crystallization of salts and voids, extreme temperature exposure like freeze thaw and structural fires. These are all these are some of the phenomena that constitute the physical durability related deterioration. And in the chemical effects, there is leaching out of cement paste due to acidic solutions, expansion of the microstructure due to several deleterious reactions like alkali-silica reaction, delayed tringite formation, sulfate attack, corrosion of reinforcing steel bars, and so on. So these are some of the chemical effects. Now, why do we want to study chemical admixtures or admixtures as a whole, and why do we want to study their effect on durability? Now, before going into that, let's know what are admixtures. So, international standards define admixtures as substances other than cement, aggregates, water, steel and fiber reinforcements. Whatever other substances that are added to the concrete other than these constituents can be called as admixtures. So these can be mineral admixtures or additives, mineral admixtures or additives, and then this can be chemical admixtures. And in today's session, we'll be talking only about the chemical admixtures part of it. Now, what are chemical admixtures? They are soluble in water and they enhance, mostly they enhance the fresh and hardened properties of concrete. And it is important for us to understand that for any given material, any processed material, since we know that concrete it's not a naturally available material, it's a processed material. Now, for any processed material, the properties of that material in its finished form will be governed or will be affected by the properties in its raw form as well as all the value addition during the processing of the material. So what I mean to say is that for any given material finished in its finished form, the properties are governed by raw form properties. Whenever the material is in raw form, that is in this context the fresh properties, as well as the processing, and in this case it is environmental conditions and exposure like curing or any environmental exposure that it is undergoing, like exposure to carbonation in the case of concrete. So the properties in finished form is affected by these the materials, the raw materials, and its properties in its fresh properties of the concrete, and then by the processing as well. Therefore, it is if we ensure that the fresh property of the material is good enough, it is in a desirable state, then we'll be able to also have an assurance that the hardened properties might also be well. However, we need to design that in a certain way. Now, use of chemical admixtures as single compounds or a combination of different chemical admixtures can provide several properties or several enhancements to the performance of concrete. One is an increased mechanical performance because sometimes addition of water reducing admixtures they cause the compaction of concrete, so they reduce the voids in the concrete and therefore they enhance the mechanical performance. They sometimes reduce the corrosion, and we'll see in the coming slides how and which type of admixtures do that. Mitigation of alkali-silica reaction, reduction in shrinkage. Yes, we'll also again discuss this in the coming slides. The water reducing admixtures and other admixtures also improve the workability and slump retention of concrete, so that if the workability is improved, we'll be able to pump the concrete easily, transport it into the site, and cast the elements easily. Even if there is a congestion of reinforcement, we can have a flowable concrete and it can fill all the gaps and voids at the site. And suppose in the case we want the concrete to be stiff, like in the case of a concrete pavement, then also we can use these admixtures and tailor the concrete to have a desired workability. They also reduce the permeability and they also modify the rheological behavior, as I mentioned. Let's say for modern applications such as shotcreting and 3D printing, all these applications, these chemical admixtures can be effectively used to achieve certain properties. However, the main reason why we need to study chemical admixtures and their effect on durability in detail is that in today's world, the use of chemical admixtures has become inevitable because we are going towards more pumpable concretes, and as I mentioned, we are going towards high-end applications like shotcreting and 3D printing, we cannot do we cannot achieve these properties in concrete without the use of chemical admixtures. Let's say in the case of UHPC as well, ultra high performance concrete. So all these applications require chemical admixtures, and therefore it has become inevitable. And also these chemical admixtures are costly, so we need to study them so as to use them effectively and to our best use, so that we'll achieve the desirable properties that we want out of them. Now, chemical admixtures can be classified majorly based on two aspects. One is based on their physical form in which they are available commercially. One is liquid chemical admixtures, and the other one is solid chemical admixtures. And the liquid chemical admixtures can be directly mixed to the mixing water, while the solid chemical admixtures, we have to mix it in the solution. We have to first make it as a solution and then add it. Based on the type of action of the different chemical admixtures, we can classify them as surfactants. So basically, these surfactants are the type of chemical admixtures which adsorb onto the surfaces of different ions and reduce the surface tension. And then there are other admixtures which are in ionized state, and they impact the reactions of cement water system. The chemical, they affect the chemical or the reaction chemistry of the cement water system. Now, the ASTM C260 standard is the standard for air-entraining admixtures. The ASTM C494 is the standard for water-reducing and set controlling admixtures. We'll be looking at these admixtures in a little detail in afterwards. And then the ACI Education Bulletin E403 and ACI 212.3R16. These codes also discuss several miscellaneous admixtures. We'll also have a look at these type of miscellaneous admixtures in a little detail in some time. Now, the first kind is that we're going to discuss today is air-entraining admixtures. What are these kind of admixtures? So, as the name suggests itself, and we have also discussed this in our sessions as well, and in the lectures you have seen that air-entraining admixtures, they entrain microscopic air voids, and these are different from entrapped air voids. We have discussed this in detail in the previous sessions. Yes, so these are different from entrapped air voids. These are smaller in size, and they kind of provide us with a ball bearing action inside the concrete. And these air voids, as we have studied in the course as well, whenever the concrete is exposed to freeze thaw cycles or freezing and thawing effects in the environment, these microscopic entrained air voids can help us in releasing the stress, so that the water or the moisture inside the concrete can get into these entrained air voids and solidify there without having a expansive effect within the microstructure of the concrete. Now, these air-entraining admixtures are basically non-polar hydrocarbon chains with an anionic polar group. So they basically, how they act is, they basically lower the surface tension of water at the air-water interface, and they make the cement particles more hydrophobic, so that the air bubbles can get attached to the solid water interface. So between the solids and the solids and water, these air bubbles can form around the solid particles, and they can cause the release of stress. Sometimes it has been seen that air-entraining admixtures can enhance the workability and as well as the freeze thaw performance. Below, at the bottom right, we can see a picture. This is a plain concrete specimen without any air-entraining admixtures, and this is air-entrained concrete specimen. And these both these concretes have been exposed to 300 freeze thaw cycles as per the ASTM's C666 procedure B. And we can see that the concrete that is that does not contain any air entraining admixtures has degraded severely as compared to that which has some air-entraining admixtures in it. Then comes water reducing and set controlling admixtures. These are typically these are what we have studied in the previous slides as well. The water reducing admixtures uh, in, increase the workability of the concrete or reduce the water requirement in the concrete, and the set controlling admixtures are basically two types. One are the retarders and the accelerators. They monitor or they control the reaction chemistry of the cement water system, and so thereby they hinder the cement hydration in the case of retarders, or accelerate the cement hydrations in the case of accelerators. These type of admixtures, they facilitate the placement, they limit the segregation, and they adjust the setting time in the case of set controlling admixtures, and also due to these properties they improve the durability. Now, the water reducing admixtures are basically the type of organic compounds which contain anionic polar groups with a polar hydrocarbon chain, and they get adsorbed onto the cement particles, making the surface of the cement particles hydrophilic in nature. Now, this ensures that the cement particles are deflocculated and do not form any agglomeration within the concrete. The set controlling admixtures, as I mentioned, they regulate the setting action. They alter the dissolution rate of the calcium and the silicate, the calcium cations and the silicate and aluminate anions in the cement pore solution, and they thereby they affect or they take part in the reaction chemistry of the cement water system. It has been observed that the lignosulfonate based water reducing admixtures also demonstrate some air entraining properties, and these type of admixtures also have resulted in the reduction of long-term shrinkage and creep in concrete, right? And this is a figure that I've taken from the literature, and this shows the creep in different types of concretes which contain plasticizers as compared to the concretes which do not contain any plasticizer. The concretes which do not contain any plasticizer are these with the hollow markers, while the filled markers show that they contain 1% and 5% plasticizers respectively. And we see that with the use of superplasticizers or I mean plasticizers in concrete, the creep in concrete has significantly reduced at the age of 500 days. And not just the plasticizing effect that comes from the water reducing admixtures, that is the reduction increase in the workability, but also in the long term durability, we see that the creep is reduced by introducing water reducing admixtures to concrete. However, when using accelerators such as calcium chloride, triethanolamine, and calcium formate, it has been observed that these types of accelerators are they cause some increase in the drying shrinkage. And below is a table which shows. I have taken this from the literature, and this shows that with the addition of calcium chloride and triethanolamine and calcium formate at different dosages, for the same concrete mix, we see that there is an increase in the drying shrinkage starting from early age till the age of 168 days from the casting. So sometimes these accelerators, even though we intend to accelerate the chemical reaction, we intend to achieve a higher early strength in the concrete. However, the use of these accelerators can result in some dimensional stability issues such as increase in the drying shrinkage, and therefore we should be careful while using such kind of admixture in the concrete. And then come the different types of the type of admixtures that we discussed till now were the major type of admixtures that are used in the construction industry primarily. And then these are some of the admixtures which are categorized under the miscellaneous admixtures, as I mentioned in the previous slides. So the first of them is the corrosion-inhibiting admixtures. They reduce the risk of chloride-induced corrosion of steel rebars, as we have also discussed this in the lectures as well. They decrease the rate after the initiation, the corrosion rate after the initiation of corrosion, and they do not require to reduce permeability extremely. And there are four different types of corrosion-inhibiting admixtures majorly. One is amine carboxylate based admixtures, amine ester organic emulsion, calcium nitrite. This is a famous corrosion inhibiting admixture, and this sometimes also acts as an accelerator. And then the fourth type is the organic alkynyl dicarboxylic acid salt. And this is a typical uh, plot of the which compares the use of calcium nitrite, 2% calcium nitrite in concrete as compared to that without the use of any calcium nitrite, and this compares the weighted total corrosion in the concrete specimens. And we can see that when there is no calcium nitrite or the corrosion inhibiting admixture in the concrete, the corrosion rate is quite high at the same age as compared to that of the concrete which has 2% calcium nitrite in it. Then come the shrinkage reducing admixtures. These are another type of admixtures, and so we have discussed the issues of shrinkage in the durability part of this course as well. And these are organic chemicals which decrease the surface tension of capillary water. So basically, as we know that the mechanism of shrinkage in concrete is caused by the transport of water or the moisture the from a certain region, causing capillary tension in that region, and thereby shrinkage cracks are caused inside the cement or concrete. So the, these shrinkage reducing admixtures, they decrease the surface tension, and therefore the even though there is movement of water, but the capillary tension is not as much as in the case when we do not use these kinds of admixtures, and therefore the stress within the concrete is or the cement is lesser. Therefore, the cracks are reduced. The shrinkage cracks are reduced. As I mentioned, they reduce the tensile capillary stress within the concrete matrix. A typical shrinkage reducing admixture is polyoxyalkyline alkyl ether. And it has been observed that some of the SRAs can cause retarding effect and increase the setting times marginally. They can also interfere with, when added with air-entraining admixtures, it has been observed that they can reduce the ability of these air-entraining admixtures to control the freeze-thaw damage. So whenever we are going for a combination of admixtures, we should keep in mind that these admixtures should be compatible with the materials that we are using in the concrete, as well as these admixtures should be compatible with each other as well, so that they do not hinder the performance of each other, whatever is desired out of them. This is a comparison between the drying shrinkage of two different concrete types when added with shrinkage reducing admixtures as compared to the reference mix, which do not has any shrinkage reducing admixtures. And the graph on the left shows the results from no curing. So the concrete has been cast and hasn't been cured till 200 days. And then the graph on the right shows the effect of 14-day curing on the shrinkage values of concrete. And I'll just zoom in a little so that it is visible. And we can see that whenever we are increasing the dosage of shrinkage reducing admixture from 0 to 2%, the shrinkage values are reducing. So this is the trend of reducing shrinkage values with increasing dosage of SRA. Now coming to the cured specimens, we can see that at early age, since the specimens have been cured, so there is a swelling inside the concrete which compensates for the shrinkage, and since we have added shrinkage reducing admixtures, so the drying shrinkage values have gone to negative values. That means there is a swelling inside the concrete, and at later ages we can if we compare these values with that of the non-cured specimens, we can see that the shrinkage values in cured specimens is a little less. So this also gives an idea of curing on the shrinkage or the drying shrinkage of concrete. Then another type of admixtures are admixtures which control the alkali-silica reactivity in concrete. These are basically lithium-based chemical admixtures, and they generate a non-absorptive gel with the reactive silica. There could be solid admixtures and there could be liquid admixtures. The solid admixtures are lithium hydroxide monohydrate and lithium carbonate, while 30% by weight of lithium nitrate solution is used as a liquid alkali-silica reactive admixture. And it has been observed that using lithium carbonate sometimes accelerates the setting times, and it might also lead to a flash set in the concrete. Therefore, special care should be taken when we are using these kind of um, alkali silica reaction reducing admixtures such as lithium carbonate. So these are the different types of admixture that we saw today that could affect the durability of concrete in the long run, and this is a non-exhaustive list of admixtures. In today's world, there are a lot of different type of admixtures that have been developed. There is viscosity modified admixtures. There are other combination of compounds, organic compounds that are being, used to produce, to tailor to different properties or performance requirements of concrete. To summarize this session, I would say that chemical admixtures, of course, play a major role in mitigating durability issues of concrete. And as I mentioned, if we want to control the properties of a material in its finished form, then we have to take care of the properties of them, or we have to design or tailor the properties of the material in its raw form, and also take care of the processing or the environmental effects that affect the material during its age. Again, we have seen that some of the chemical admixtures can mitigate more than one problem. Like we have seen that some of the admixtures can act as accelerator as well as corrosion inhibitor, like in the case of calcium nitride. However, the compatibility of these admixtures with other materials and with different admixtures when used as a combination should be ensured before adopting in a mixed design. So that will be all from my side in this session. These are some of the references that I have used to make these slides. If you have any questions, I'll be happy to answer you.
Good evening, sir.
Yes, good evening.
Uh, what is the relationship between the admixture and type of cement content we choose to use in concrete, sir?
What is the relationship between what and what?
Admixtures and
Admixtures?
cement, different types of cements we are having, sir.
Okay, right. So, yeah, so with the
For
advancement in
example, we
technology,
have ordinary Portland cement,
right, right,
Portland slag cement.
right, right, right.
What is the relationship that you conclude with this cement content and admixtures? Is there any relationship, sir?
Yes, of course, there is relationship. So, whenever you're adding supplementary cementitious materials to to
Ye-
produce cement, like blended cements, for example,
Yes, sir.
be it
Yes.
binary, ternary, or quaternary blended cements, uh,
Yes, sir.
these supplementary cementitious materials are finer materials, and due to their morphological properties, they entail higher amounts of water and they require higher amounts of superplasticizer. So we have seen that in the case of blended cements as compared to that of OPC, the requirement, admixture as in when I'm saying admixture, I'm talking only about water reducing admixtures or superplasticizers per
Yes, sir.
se.
Yes, sir. Only
Yeah,
water reducing
yeah.
admixture.
So the admixture requirement increases in some of these type of blended cements. But again, it varies from cement to cement. Like the morphology of the particles governs the admixture and water requirement in concrete.
Okay, sir. Okay, sir. Thank
Right.
you, sir. Thank you, sir.
Okay. Yes. Any other questions? If you have any other doubts related to the lecture sessions as well, you can ask them. All right, we're closing this session. This was the last TA weekly discussion session of this NPTEL course. And I'm thankful to everyone who's attended these sessions. At least it was very helpful for me. I learned a lot while the fruitful discussions that we had during these sessions. I hope it was also helpful for you as well. I also want to dedicate my special thanks to Professor Pillai, who has designed this interesting course. And while working as a teaching assistant, I could learn a lot by looking at his lectures. So, thank you, everyone.